Okay guys, so in this example we have the function f of x equals the square root of 2x plus 1, and we want to evaluate the f prime of that function at 4. So f prime of 4. For our very first step is you say, okay, f prime, you write your formal definition. It's going to be the limit as h approaches 0 of f of x plus h minus f of x over h. We know what f of x is, but we don't know what f of x plus h turns into. So this is going to be the square root of 2x plus h plus 1. Okay, so now we want to basically write that again without those parentheses. So we're going to get the square root of 2x plus 2h plus 1. Okay. Pretty simple. So now we basically use this new expression and we plug it into our formal definition. So f prime of x is going to be the limit h approaches 0 of the square root of 2x plus 2h plus 1, and then minus the original, which is 2x plus 1. Okay, let me put that little wiggly thing. Alright, and then the whole thing is going to be over h. Alright, so now we want to use that, basically that conjugate rule, to basically be able to eliminate some terms. Alright, so this is going to be multiplied by the square root of 2x plus 2h plus 1. Instead of writing that negative, you're going to write a plus, and then 2x plus 1 here. Okay, similarly you're going to do the same thing at the bottom. The square root of 2x plus 2h plus 1, and then plus the square root of 2x plus 1. Alright, okay. We close that out, and now you're going to use your distributive property. So you're going to get the limit as h approaches 0 of all your square roots are going to go away. Okay, for the numerator. So that's going to be 2x plus 2h plus 1 minus 2x plus 1. So that is the trick of the conjugate, that essentially you just get rid of your square roots on the top, but not on the bottom. So basically you're going to write still 2x plus 2h plus 1, okay, and then plus, okay, the other one, 2x plus 1. Alright, forgot to write that 1 over h, so simply just write it outside. Alright, now that we're good, we want to eliminate terms. So this is very, very rudimentary. It's kind of like routine. You follow it with steps. So get rid of your 2x and your 2x over here. Get rid of your 1 and your 1. This h and this h disappear or cancel out. And so now you're left with this. This is going to be the limit as h approaches 0 of 2 over 2x plus 2h plus 1 plus 2x plus 1. Okay, and so what happens? Let's apply that limit. So if you apply it, you get rid of this term. Alright, that term goes away, and so in the end your f prime is going to be this. F prime of x is going to be 2 over 2 times 2x plus 1. Alright, so that wasn't so bad. Now we forgot to evaluate the f prime at 4, and we're going to get 1 over the square root of 5. Okay, simply substitute the value of 4 into x. Alright, so let's do one more problem, and we're going to go ahead and call it. Again, if you have any further questions, make sure you post that on the comments or send me a private message. Okay, so boom, let's do this one. Okay, we have a slight change here. Now we're entering into some square terms, so don't be afraid by that. That is just simply there. But what's our very first step? You simply write your definition of the derivative. So f prime of x is equal to the limit as h approaches 0 of f of x plus h. At this time, I know you're basically hearing it in your sleep. So that's what we want. You want to memorize that thing and just say it every time you write it. Okay? Wash on, wash off, that kind of thing. Alright? So, you know what f of x is. You do not know what f of x plus h is. So you evaluate that and you're going to get x plus h squared plus 2. Okay? Now remember, you're writing x plus h instead of x, so that's why I put an extra parentheses there. So you simplify that, and this is what you're going to get. The square root of x squared plus 2xh plus h squared plus 2. Boom. Okay? So we're good now. We are going to plug this into our formal definition. So f prime of x is going to be the limit as h approaches 0 of this thing here that we just evaluated. So that is going to be x squared plus 2xh plus h squared plus 2. Okay, minus the original, so x squared plus 2. And then this whole thing over h. Okay, what's next? We're going to use that conjugate expression. Okay, so what are we multiplying here by? We're going to multiply this whole thing by x squared plus 2xh plus h squared plus 2. Instead of writing a minus, you're going to write a plus and x squared plus 2. Close that. Do the same thing at the bottom. Okay, so that is going to be x squared plus 2xh plus h squared plus 2 plus x squared plus 2. Okay, close that. Okay, so now let's basically use that distributive property. I'm going to go ahead and allow you to do that, but suffice it to say that when you apply this conjugate rule, you're going to get rid of the squared root terms at the top. Okay, so you're going to be left with x squared plus 2xh plus h squared plus 2 minus x squared plus 2. Okay, and make sure you put that in parentheses. Alright, the next thing is nothing happened at the bottom. Nothing happened at the bottom, so you're just going to write your big old expression, okay? I'm sorry if I'm doing this to you. Plus 2x plus h squared plus 2, okay, plus x squared plus 2. Alright, so, okay, I forgot to write my h, so instead of dividing this whole thing by h, let's multiply it by 1 over h. What is next, guys? Eliminate terms, okay? So let's get rid of this. Let's get rid of this. Let's get rid of this 2 and this 2. Okay? We have one h here, so it basically goes away. This h goes away. This exponent goes away, turns into 1. So now let's see if we can apply our limit as h approaches 0. So it's very important that you eliminate terms before applying the limit. So let's see, f prime of x is going to be the limit as h approaches 0 of 2x plus h, okay, over this big old huge expression which I hate, and I know you hate too, so don't even think I don't know. X squared plus 2xh plus h squared plus 2, and then plus x squared plus 2. Okay? Apply that limit now. Let's get rid of terms. This is so fun. This goes out, this goes out, this goes out, and you're left with something beautiful. F prime of x equals the limit as h, oops, I don't have to write that again. Okay, sometimes I become a beast of habit. So it's going to be 2x over 2 x squared plus 2. Okay, so simplify that a little more. X equals f prime of x equals x over x squared plus 2. Alright, and suppose you wanted to evaluate that prime at 1. So simply you're going to be left with f prime of 1 is going to be 1 over the square root of 3. Okay, you can simplify that more, but I think we're good. Alright, this is all you need for Friday's assignment. Alright, I get it. You know, applying the formal definition is definitely not an easy task, but it's going to be rewarding. We're going to enter into the realm of derivative rules, so that is going to make our life easier. Alright, and this is the last time we apply the formal definition as such. Okay, so good luck. Send me any questions that you have, and I hope to see you next time.